Welcome, ladies and gentlemen, to your video lesson on area of composite figures. Be prepared to use some paper and show your work going vertically. I'm going to show you the most organized way that I can, and I really encourage you to follow that rather than writing all over the place and not knowing what goes together. So please do your best, one line at a time, and just take spaces when you need to be organized. It's really going to matter here. So first thing you need to know is that there's new vocabulary, which is composite figures and semicircles. A composite figure is made of triangles, quadrilaterals, semicircles, and other two-dimensional figures. So it's really a shape that's made up of two or more shapes, two or more two-dimensional figures. So here are some examples. A trapezoid connected to a semicircle, which is a half circle, that makes one shape. A triangle connected with a rectangle makes another shape. Sometimes you'll see more than two figures attached, okay? So we're going to have you right away start off. Might be a good spot if you didn't print the notes to maybe pause, maybe trace the shape. Don't take forever doing that, but make sure that you can read the parts of it and then follow along and then pause at the end and try. Really just do what's best for your learning. Do not chase me. So first thing you have to do is determine what shapes that you see, and we all might see this differently. Someone might cut this shape into three pieces, seeing maybe a square, a rectangle, and a triangle. That's fine. I try to cut into as least shapes as possible to make it easier for me when finding the area. So what I see is if I cut it right here, I have a triangle and a rectangle. So how I show my work is that I first decide what I'm finding. So I say that I'm finding the area of a rectangle plus the area of a triangle. Bear with my stylus again. So then what I do is I record that I need the area formula first for a rectangle. And again, you can use base times height or length times width. I'm going to use length times width today so I don't get that mixed up with the height and base of the triangle. Plus area of a triangle, which is 1/2 my base times my height. So knowing the formulas is very important. Organizing them, knowing that you'd be adding those areas together to find the area of the whole shape is also important. So next, when finding the parts of them to plug in, finding the length and width of the rectangle, my length here is 10, my width is 6, so I'm doing 10 times 6. For the triangle, I put my 1/2 in. I have to find the base of the triangle. Well, notice here is my base of the triangle because this is my vertex. So I can see this is my height from the vertex to the base, but my base is here. That's not 6, and that's not this full length of 10. So notice this whole way right here is 10, and this is 6. That means 6 plus what number is 10? Well, you can see that this number here, that base, is 4. That 10 minus 6. Okay? So my base, we decided, was 4, and we decided the height was also 4. So then I do those separately. I find the area of my rectangle, which is 60, plus the area of my triangle. Half of 4 is 2. 2 times 8, 4 is 8. So I find that the area of this composite figure is 68 square inches. So notice, that might have gone too fast for you. Make sure you pause and go back if you need to. I wrote down each formula, blank, plugged into each formula, did them separately, and added them together. Okay, so it's the sum of the area of the shapes it's made up of. Please work down and show your work. Writing all over will not help you. Okay, a couple more. You're only doing a couple examples today, so when you are ready, do those with me or work on your own and then come back. First thing is to decide what shapes you'd like to see. So if I cut it right, where should I cut it? I'm going to cut it right here for a triangle and a rectangle again. So I'm going to find the area of a triangle plus the area of a rectangle. So I need my formulas. 1/2 the base times the height plus the length times the width of that rectangle. So I plug in. The base of my triangle, notice, is right here. Well, let's call that x. This whole side length is 12. This is 8. So what number plus 8 gives me that full length of 12? And I know that that is 4. My height of my triangle, notice here, if this whole side length is 10, and from here to here is 4, that means this remaining part is 6. So notice I'm using some of those solving equation pieces to help me. So then my length of my triangle is 12. The height is 4. And you have to be very careful, because I think originally when I made my notes before this video, I said the height of the triangle was 10. Well, that will not give me the correct answer. So then I work it out. Half of 4 is 2 times 6 then is 12 plus that 48. So I find out that the area is that 60? 60 square feet. Okay, if you're feeling ready now, making sure you're showing your work like that, that is a priority to keep organized, then you can try this one. Notice there's another difference. We have a semicircle now, half the area of a full circle. So I'm looking for the area of a rectangle plus the area, I keep making that triangle, of a half circle. So I write down my formulas. Area is, rectangle we know is length times width. Half circle, we know a circle is pi r squared. Well, half of that would mean to divide by 2. So I'm going to plug in what I know. My length is 9 2/10 times my width of 1.5 plus, plug in pi, my radius. Notice, okay, so this is a little tricky. We have from here to here, which isn't labeled. We have here to here, which is labeled 2.5. From here to here is 9.2. So what we do is say 9.2 minus that 2.5, and we get 6 7/10 is the length from here to here. Well, that would mean that that's our diameter. Half of that is our radius. So half of 6 7/10 is 3 35/100. That's our radius. So that goes right in there. And that is being squared. And then all of that is being divided by 2. So you have to be very careful. And again, showing your work matters. So then I'm going to work this out. When I do 9 2/10 times 1.5, I get 13 8/10 plus, maybe I don't do all of this at once. I'm going to use 3.14 for pi. I'm going to square first. So I did this squaring and I get 11.2 approximately times pi. So I'm at approximately 35 24/100 divided by 2. Notice I don't just plug it all in the calculator. So then I work down. I have 13.8 plus, when I divide that, approximately 17 62/100. Add those together. My area is approximately now, because I rounded, 31 42/100 square centimeters. So again, there are some things that are going to come up where you have to take your time and think and not be distracted and show your work. Last two, ladies and gentlemen, these are going to be your real world problems. Building things, a lot of times you use your composite figures to find the area. So if we have a pool here, we're going to find the area of the pool's floor. So find your shapes. I see a trapezoid and a rectangle. So I'm doing area of a trapezoid plus the area of a rectangle. So I write down my formulas. Trapezoid is 1/2 the height times the sum of the bases. Use my brackets to know that's separate from my area of a rectangle, length times width. Plug in what I know. The height of my steps there that's in the shape of a trapezoid is 2. Base 1 is 4, base 2 is 6. The length of my pool is 28 feet. That'd be nice, wouldn't it? And the width is 14 feet. So then I work this out. Half of 2 is just 1. So that cross cancels, and I just have 4 plus 6, which is 10, plus 28 times 14, which I believe is 392. So then I add those together, and I have an area of 402 square feet. All right, very last one. You guys have been very patient and wonderful. I'm hoping you're showing your work and coming with questions. And I keep bumping my table. So this next one also is a little tricky, so look at it. Maybe pause and decide what shapes you would see. If you need to turn it, cut it with your marker, that's fine too. What I did is I cut the shape again right here, and I saw that I had a trapezoid, a rectangle, or really a square, and a trapezoid again. So my area, and I thought for a second maybe those trapezoids are the same, but I noticed that they're not, because this is 10, and if this whole thing is 36, and this is 20, I have what number plus 20, which would be the same right here, plus 10 is going to give me 36. So I noticed that that last side had to just be 6. So I know that they're different. So my formula is going to be first trapezoid, which is half the height times the sum of the bases. The rectangle, which is length times width. And another trapezoid, which is going to have that same formula. Notice I still write it out because I don't want to make any mistakes here. And you have to recognize that these values are going to have different values, even though their labels look very similar. So I plug in what I know. So I call this trapezoid 1 and trapezoid 2 if I'd like. So for trapezoid 1, I have 1/2. The height, which we decided was 6. Base 1, which is the same on that side, is 14. And base 2, which is the same there, is 20. Plus my length and width of this rectangle is 20 by 20, and I know it doesn't totally look like a square. And then the trapezoid 2, my height is here, from base to base is 10, where base 1 is 14 and base 2 is 20. So similarities, yet their heights are still different. So I work that out, maybe one shape at a time. So I get half of 6 is 3, and I'm multiplying that by the sum of the bases, 14 and 20, which is 34. Adding that to the area of the rectangle, which is 400, and that to half the height, which is 5, and the sum of the base is 34 here. So notice again, I'm seeing exactly where I'm working, rarely needing the calculator or plugging it all in and just working down to make sure I find any mistakes if I make them. So then I do 3 times 34, I get 102, plus that 400, plus 170. Again, I keep working down, so I find my area is, add those, 502 plus 170, and last but not least, 672 square feet of deck material. So it's kind of a lot, showing your work going down, but it will save you in the long run. Do your best. Good luck.